All right, so we have our kitty waking up. I've actually taken out all the print lines here, so if you want to do that, clean up your code and move from there. But how do we make the kitty move? Well, little tip. If you wait until the mouse is over the cat, it's too late to do anything about it. Because once we're over the cat, I can no longer tell did I come at the cat from above or below or from left or from right? Right? So if you think of this, I can draw a tic-tac-toe grid with the cat in the middle. And top left, I don't need to worry about, and top right, I don't need to worry about, and bottom left and bottom right, I don't need to worry about. It's only when I'm getting close to it from top, bottom left, or right that I really need to move the cat at that location. So it's not really just enough to know when I'm over the cat. Again, this picture has a little bit of buffer on it, but you can see I can get over the cat here. If I don't want to allow anybody to actually touch the cat, I want the cat to run away worried before I even touch it, I need to give myself a little bit of buffer around the cat. And so the easiest way to do that is add it into our logic, right? So I'm going to create, you know, a buffer. I'm going to put it capitalized because it's going to be something I'm going to use throughout the rest of this method here. So I can make the buffer as many pixels as I want to. So I can do 10 pixels, I can do 20 pixels, I'll do 50 to give myself plenty of buffer there and see what it looks like. And I can always tweak it later on. I'm doing a constant so that way I can shave that buffer without having to worry about it. So now that I have this notion of a buffer, I can actually make the cat get worried before I touch it. And then I can move the cat when I hit the buffer, and then I never have to worry about getting super close to the cat, right? So let's see. There's a couple ways I can apply the buffer. So one of the ways is I could actually apply the buffer around the cat itself. So I could shrink the X by the buffer and the Y by the buffer. So I could do that. Um, but in doing that, I want the buffer to be on the either side of the X and Y over here as well. So I need to do this plus 2 times the buffer on each of these. So let's see if that gets what I'm looking for. Because I could also add the buffer into my logic here, but maybe this will be good enough to get the same effect of what I want. So let's check it out. I'm sorry, run it again. So moving down. Oh, look at that. The cat wakes up long before I get there. And 50 is a lot of characters away, a lot of pixels away. But notice I can't get anywhere close to the cat before it wakes up. So that's good, right? So that gives me plenty of space to wake that up, and my logic works pretty well. So all around it's fine, but if I get close, oh, the cat wakes up. So cool. So when the cat wakes up, then I want to move the cat. Well, how do I move the cat? Well, the cat's just a component, right? It's just a label onto a display. So all I have to do is say self.cat.move it. Let's place it somewhere. Again, we did a place up here at the location for the cat. So, well, what if I just say the place? Okay, well, the one downside of changing it this way is now I've lost my location for where the cat started. But that's okay. I just used the long variable right there. It's not the end of the world. But let's just see. So if I say, okay, well, when I get close to the cat, let's move the cat over by one spot. Let's make this X and Y. We'll just shift the cat over a little bit when I get close to it. So let's see what happens there. Oh, see there, the cat moved away. Oh yeah, cool. The cat runs away. I can't touch it. Okay, so the cat ends up getting off the screen. So I probably need to accommodate that so that way when the cat is bigger than the screen, I have the cat jump somewhere else or something like that. Maybe just teleport to the other side. But it's always useful to do more than one test case. So let's watch this. I'm going to get closer to the cat from down here. Oh, what just happened? Oh, yeah. So when I come from the bottom and the left, I don't want to add to the cat. I want the cat to run away the other way. I need to be sensitive, aware of which direction I'm coming at the cat from. So that means the buffer is helpful here because I can tell long before I get to the cat from which direction I'm coming. But I need to have a lot of code here because I have to decide, am I above the cat, am I below the cat, to the left of the cat, to the right of the cat? So that's going to be a whole lot of if then else statements right here. So what do I want to do? Well, I need to move this functionality somewhere. One of the best ways to do that is to create a helper method. And you can just say move cat at this point. There's some good reason to do that. There's some reason not to do that. You can decide. I mean, let's just say here, I want to move the cat. I can create a helper, but then I have to decide, well, where am I moving the cat here? I can just pass along the event here, but that kind of becomes confusing because I have the event in two places. So I might do that, but I'm going to take a different approach for now. I'm going to create a variable. I want to know when I'm close, right? So when I violated the buffer, I want to know that I violated the buffer. So I'm going to take this line out for a moment. I'm going to say close is equal to true. So at this point, I know I'm close. I know I need to do something. But I want to think about this for a second. And before I create another method, which I still might do, I want to say, well, if I'm close, I'm going to do something. I'm not entirely sure what. So I'm going to go put this back down here again. But I got to decide, like, well, I don't want to, oopsie, there, I'm already jumping around. I don't want to jump around like that. So maybe I'm not going to do +1 or -1 all the time. So right now, I'm just trying to separate my mind, spotting when I need to make my cat worried versus spotting how I need to move the cat. So that's a nice little code small strategy. Oops, I hit F1 accidentally there. So let's see. So I really want to say, I'm going to shift X and I'm going to shift Y when I know I'm close. And I don't know what I'm going to shift. So I might be doing 1 and 1, but I might also be doing -1 in one way or another, right? Shift X and shift Y. So for example, let me just say I make Y -1. So I'm going to move to the right and up in some situations. So when I come over, shoot, I'm still going down. Well, what's up with that? You know, why is that happening, right? Well, it's important to, again, understand one small thing at a time. So I know I have a problem here that I want my cat to go up, down, left, right based off of the way the mouse comes in. But notice when I'm going to make both these negative here for a second. Oh, look, they're still moving down. I made them both negative, but they're still moving down. What the heck's up with that? Why is it happening? There can be a lot of problems that hit you all at once in a program if you don't understand all the pieces. So here, well, let's make sure what the heck just happened. So let's print the XY location of the cat before and after what this place move and see what the heck's going on here. So why is it moving down? So let's look. Well, it's actually not moving at all. That's the first one, right? And then when it moves, this got bigger, and this got bigger by a whole lot, not by a tiny amount. Well, this is a tough thing to figure out. And I'm not going to make you figure it out. I'm just going to kind of tell you the answer because just in the interest of time, this is a matter of the relative positioning system that we have going on here. So when we place something here, we did 300, 200 to start with. And when we place something at the root info, that actually messes stuff up a little bit. We actually want not the root info, we just want the XY location of the cat inside of there. And that's what we're going to shift up or down. So watch instantly what happens with this little quick shift. Oh, see now look, the cat's moving very slowly. It's moving up and to the left. Much better. Now, again, I can make it move down to the right by hitting my X shift and Y shift, right? Or I can make it move some combination therein by having my X shift and Y shift, so up and to the left. And there, by the way, there should be some situations where it only moves left or it only moves right. I don't necessarily need to move all directions at once. But the important thing here was I encoding small and not trying to solve that whole problem and write all that if then else structure of figuring out where it is at once. I now figured out a bigger problem that I had, or at least I gave you the answer, that I figured out on my own as I was playing with this, that this relatively positioning thing is important. So let me actually run this one more time so we can look. Notice here now how subtly this is changing one at a time instead of making those big leaps. Because the relative position here is not the absolute position. And so what actually is happening when I say x root uh, root x root y, it's actually not looking at the location relative to the window up here. It's actually, if I move over this, notice here how all of this has changed. I've actually put it on my other monitor and see how big that X value went changed, because the win info is in the top left corner of the window. The root info is the top left corner of the screen. And I need to be differentiating those because the root info up here is important because it is relative to the top of the screen and thus doesn't change from when I move over one component to the next. The win info is important down here because I'm positioning it relative to the window instead of making the big jump to the different coordinate system, which is why it makes that huge jump and it's a much bigger number. So that is a really interesting conundrum of understanding the Tinker system much more than anything else. And I wanted to show this little debugging thing to you because, yes, it might, this is a little silly problem, but it's more about that strategy of how do I find my problem. When I print out things, I can see, wait, those numbers don't look right. And you might not have even noticed the numbers don't look right. But with experience, with playing with it, with looking at those numbers, you can start to get the feel for when things are just a little bit off, when they just don't quite make sense. And you can start to debug those things. Not that they're always going to come easy like this. And when I went to go find it, it didn't come easy. It took me over an hour to find it. But I can share that knowledge with you here and maybe show you hints on how you can find it for yourself. So we'll continue on. We're not done with our mouse yet. We've started the next little bit. We have our mouse moving a little bit, but let's get a little bit smarter, but we'll come back to that in a second. But make this work in the meantime. Play with this. Make sure you're keeping up, and then you can go to the next step as we get our cat running away from our mouse.